Most robots in the world today run on a lot of if this, then that. And that worked in labs and pilots. But at Formant, we have witnessed how it often breaks when that meets the real world. So today I'm talking to our head of AI, Richard, about why we think we're finally moving from rules to principles in robotics. And if you've been wondering why physical AI matters, this is for you. So Richard just published a piece on our blog called Physical AI from Rules to Principles. We're going to unpack that article. We're going to talk about what we have learned from actually deploying robots and get into the details of what is now possible. So, hey, Richard, thank you so much for doing this.
Hey, glad to be here, Henrik.
Let's start with why. A lot of people listening have probably seen the words physical AI floating around LinkedIn or slide decks, but it sort of means anything or everything to everybody. So someone like yourself who's deep in robotics and AI, how do you explain what's actually at stake with physical AI?
Yeah, so I know it's a very nebulous word to a lot of folks. What I really see is at stake and what physical AI tries to target is bringing robotics and the goals that they accomplish to more and more places. I think we have robotics that are applied in lots of fixed warehouses that are doing very specific things. And I think what's exciting a lot of people is the idea that robots can be doing generalized tasks. Particularly, I think a lot of people are talking about humanoids and the ability they have to do a huge variety of tasks in a world that's made for humans. Physical AI, taking this combination of robotics and newer forms of AIs like LLMs, opens up opportunities for them to do much more creative tasks and work in environments that are a lot more dynamic. So I think what's really at stake here is the future where automation is making our life easier.
We're on record as saying physical AI would lead to an explosion of things done with machines in the real world, which is what you're saying. What gives you the confidence? Why now?
Yeah, I think why now is there's been a huge amount of advancements in AI beyond the traditional neural networks that have been really predominant in robotics. Particularly, there's a lot more understanding about just describing certain problems to machines and being able to get structured output that can help make decisions with very complicated inputs, more than just visual, but really all these AIs that are able to take multimodal sources, whether it be the images coming off the camera, the documentation from the robot operations specialist on what's happening in the environment, to sound. AI is increasingly able to take in all of these sources together and formulate decisions that are much more powerful than I think were possible before. And in particular, I think we're discovering some really powerful techniques with LLMs that allow us to reason about problems that are very long ranging and perform tasks that are more future thinking than purely reactionary.
So you're not talking about this in the abstract. You've been building and shipping systems for a long time. Can you share a bit about your background and the kind of systems you worked on that maybe have shaped your current thinking?
I can think back to one particular scenario that, in my mind, really defines kind of the difference between the past and now. I was working with the team here in Formant. We were working on this Boston Dynamics robot in this environment, and we were trying to get it to pick up a particular item in the environment. And this was pre-LLMs, and we needed it to pick up a hammer that was on the floor. And the difficulty in having Boston Dynamics be able to identify the hammer and get the exact point where to pick it up. And it was like we had to hire someone to really work on formulating this vision model that was so specific to just this hammer. And then suddenly, several years later, vision language models are all over the place. And asking AIs to describe what's an image is totally common. And we even have vision language models that are able to tell you all the little points of things that are, tell me where the hammer is, give me the XY position. And it's such like a night and day perspective now between what we had to do even just 3 years ago versus the superpowers that these newer AIs are giving us today. And
so at Formant, you have seen a lot of customers get stuck in what you could call a perpetuate pilot, where robots never really quite make it into these scaled, boring, everyday, super useful things. So what patterns did you see in these deployments that ultimately just made them not succeed?
you can only look at so much data. You can only look at so many dashboards. And I think there's limitations to people's time and being aware of things, and even the complexities in setting things up, like setting up a dashboard and setting up SQL statements to, look at all these streams of robotics data that are flowing through to even generate the trigger that you need to set an alarm, right, is a lot of work. And
Yes.
so historically, there's just been a lot of work to even observe things. And it's why I think customers that have come to Formant in the past is just, creating robots is already hard enough. But then creating systems to take in the data and monitor it all the time is hard enough. But then there's also additional challenges of just setting up the observation of it has been really challenging. And, these are all on top of the additional problems of just robotics themselves and people needing to set up robots in their environments and not knowing how to configure them, not knowing how to fit them into their existing processes and deal with their dynamic worlds that they have there. And now in the environment today, we have AI helping us solve sort of both these aspects. We have more autonomous AI observation that instead of you setting up a dashboard can just crawl through your databases and look up data. It could even auto-suggest views to build for you. And
Right.
as I mentioned, these AIs through LLMs and more principle-oriented automation can handle much more dynamic environment.
Yeah. No, that makes sense. It reminds me how we often reflect that these physical operations that we work in are data rich but action poor. It's not the availability of information, it's almost the amount of it and the ability to make basic sense of it, where AIs now make such a difference. Let's get into the core idea from the article. You're talking about moving from rules to principles. So in the piece, you made it pretty clear that rules weren't a mistake, they were a necessity. So why did robotics have to be rules first for so long?
So I would say it might be necessary in the sense that technology didn't exist that allowed people to step outside of it without huge investment. But also there was just a lot of huge opportunity for rules-based systems.
I'm hearing you say that if the rule-based systems were the lower-hanging fruit that the technology enabled at the time, maybe those fruits have now been picked.
Yes.
And now, in order for a true explosion of things done with machines, new technologies needed to emerge. That essentially leads us to the argument that you make that current AI models changes the constraints. Instead of encoding every behavior, we can now encode how to think about behavior. So for someone who doesn't live so close to the technology, how would you explain this shift from rules to principles?
The challenge with rules-based systems, much like rules for you give to humans, is that as soon as you encounter a situation that the rule doesn't apply, they either need to stop and go ask someone, right? Like if you tell a rule to a kid to like never cross the street, well, it's like someday they may need to cross the street and then they need to ask a person like if they can. But
Right.
if you tell a child to try to always be safe, now suddenly that opens up new possibilities of crossing the street in certain situations and handling things that aren't just necessarily street.
I'm smiling at this example because I'm a dad. That was my very first thought when you first presented me with this idea of rules to principles, right? When my kids were younger, they were still, as biological entities, they could take inputs, they could do a lot of things, but they somehow lacked the processing power to keep themselves basically safe in the world, right? As a result, we needed a bunch of rules. Then now that my kids are around teenage years, obviously we operate from principles instead. We're like, keep yourself safe and do things. And in so many ways, I wonder if you could say that this is sort of the growing up of robotics and advanced machines that we're seeing here.
It really is. And, when it comes to raising kids, it's challenging for us as parents, right? Because really these concepts of safety come from experiences of countless times that we've seen associated with that term. Right. And kids just don't have that benefit of experience. Right. And we have to tell them crude rules because they haven't had that experience to even know what real true safety is. And very much in robotics, we were benefiting from like these off the shelf foundation models. Right.
That's right.
It would take a long time for someone to create an LLM that held these concepts of safety, efficiency, profitability, and even older technologies like neural networks have not been able to capture those. They've been used primarily for maybe classification of extremely narrow situations, like only being able to tell, is there an apple in front of me or is there an orange? Not like the complete variety of human values that exist out in the world that have ever been written. And so, yeah,
Mhm.
we're really raising our robots from infants to something closer to an adult through
Right.
these LLMs that give them access to human concepts and allow us to use the principles, which really are rules of how we use these more adult concepts.
You're making the point that the AI is the thing that really makes the difference here. So help us understand, what information is this AI looking at? What's actually different under the hood between the rules version and the principled versions of things?
I think what's really different about it is the capability for language learning models to be able to take data and classify it into new types of situations that can be combined together with language reasoning. And so noticing that the battery level is 50 is pretty easy, right? Being able to take out, some raw stream and have something that notices that it's 50, right? But being able to take in, say, the battery life, your position in a map, going to some location, other robots that have missions that they're trying to accomplish, taking in all of that at once and trying to classify that into a particular kind of situation is very difficult. And for us as humans, it's very easy to do.
Hmm.
We just
Hmm.
look at this and we're saying like, oh, these two things are working together, and this guy has a little bit less battery, but they need to do something important. For machines, that has not been something that has been easy to do. But now we have the power of LLMs that have been trained on countless amounts of human text and data and turning those into, you know, to situations that it's able to think about and combine with reasoning about questions about it. So, somewhere out there has been someone who has written about how they handle a particular situation, and it got put on the internet, and some LLM provider scraped it off the internet and saw an argument of how it would handle a certain challenging situation and turned that into data that could be generalized for similar risky situations or similar situations with trade-offs. And so like the LLMs have been able to take the patterns of language, take the patterns of thought that
Hmm.
have been written in English in countless number of scenarios and allow us to apply that to large amounts of data, not only in summarizing it, but then thinking about what to do with it next. So yeah, the LLMs really allow us to turn data into more conceptual ideas and work with those conceptual ideas much more similar to how we think and how we write.
Yeah, that makes sense. That makes sense. I'm struck by how it's really this harnessing of collective intelligence that's
Yeah.
so unique in this moment. And you also talk about AI agents, which is something we think a lot about these days,
Yeah.
and how they use tools, telemetry, maps, APIs, and so on. Sort of for more technical listeners, what does it concretely look like for an AI system to use tools to act in line with principles?
When we talk about having principle based AI in physical AI, what we're really talking about is combining LLM's analysis with declarations of human values, right? And so taking a translation of of an AI that can read some data and choose a tool, but also combining the human judgment of how it should maybe be focusing on that. Out of the box, foundation models have been trained with existing writings. The writings and decisions of people out there in the world may not necessarily be the same as those at your particular business, right? You might
Mm,
think differently because you are a mushroom robotics company than the rest of the world who don't possibly care that much about mushrooms. You might
mhm.
have different things you value if you are a pharmaceutical company that's trying to apply robotics than someone who is, say, a shipping company that's trying to be robotics. You might value safety way more than you value efficiency. What I think principled AI looks like is helping focus these foundation models so that they can make judgment calls about your data and what tools they use more in line with what you actually want.
Yeah, that makes sense. I like this idea that it's the collective wisdom of the models that meets the concrete context of the business that makes these things useful.
Definitely.
So you're not saying throw away all rules. You explicitly keep rules for hard safety boundaries, regulations, just basically constraints that really are non-negotiable.
Yeah.
Can you give examples of where you really would want to have a hard rule and not rely on principles alone?
The risk with LLMs is always like hallucinations. right? It's something that even when you're, being principle oriented and setting up large guardrails around what LLMs can and can't do, you are giving it guidance, but ultimately the robot itself is the thing that is closest to the physical world, right? And
Hmm.
so even if you have an LLM that tells something to move forward to drop off a package, right? The sensor is the thing that is closest to interacting with reality, and rules like seeing like, hey, the wall's right in front of me, I can't actually move forward. That is a more accurate picture of reality than the LLM. So, adhering to the sensors and creating rules around that, are still super valuable. The LLM, while great at conceptualizing lots of data, is less connected to reality than the sensors itself. And so rules
Right.
that are closer to the sensors oftentimes still make sense.
Yeah. No, that makes total sense. It's like you trust the AI up to a point, and then you're really also saying there are lines that can never be crossed, and that's where you need a rule. In the article, you have this line: principle scales, rules don't. From a systems design point of view, what do you mean by that?
It really comes down to what are principles and concepts trying to do.
Hmm.
They're trying to give you advice for a large number of situations that are unified by, some commonalities to them. So rules oftentimes are about defining how to respond in very narrow quantitative situations, such as like how far you are from a wall, what's your battery level at the exact same time. If you are in a very strict environment that a lot of variables are controlled, you might be able to scale the optimization of that through just rules. But
Hmm.
oftentimes we're in environments that are very dynamic. As we create these more generalized robots, we need principles that allow them to deal with the vast variety of things that are coming their way. When we think about as a
Right.
human, right, how many weird obstacles get in our way of living just in a day at our house, right? It can be quite complex. And certainly when you start going out into the world, say with autonomous vehicles, suddenly just the things that can cross your path are huge. From people cutting their bicycle in front of your car to some bent stop sign to some
Hmm. Hmm.
situation where there's traffic. Um, and so I think when we talk about principal scaling, we're talking about that they scale for the vast variety of situations that we're anticipating come up in the world. But I also think that even just even just from like a situation of analysis, I think that there is a scalability that can occur in exploration of problems. So I mentioned earlier about how AIs aren't just great for having robots do things, but also exploring the data of what the robots are generating.
Hmm.
I think that if we try to define exploration as a fixed set of rules, if battery level low, run this SQL query. If this SQL query returns something over than 6, then look at this SQL query. We'll very quickly realize that even just that analysis of data is very kind of narrow, how many places you can
Hmm.
end up. If we start to create like principled exploration, I think we start creating levels of analysis that can ask really creative questions. And I
Right.
think that's what people love about LLMs today in particular, is their ability to formulate SQL queries themselves that look at data from perspectives that humans didn't just program in.
Hmm.
And when we create principles that allow them to guide their exploration, to maybe give them a sense of what data is representing and what values you might care to like extract out of those tables, I think you can even get to some very interesting scalable exploration. So
Right.
it's the combination of principles scale not just for handling robotic situations of physical AI out there in the world, but they also scale in asking curious questions about data.
I think most of us who love jamming with things like ChatGPT and can often feel delighted at what comes back on us can relate to what you're saying here, right?
Oh
It's
yeah.
like it almost starts to feel like you can take so much data into account that the systems almost acquire what you might call emergent properties. Like they will show you things, like the real world will show you things with odd connections that you could never have sort of conceived of in
Oh
this
yeah.
bottoms up way. And that's interesting, and certainly starts to get at concepts like intelligence in quite interesting ways.
Definitely. I really love it when AIs search pages that I never would have. if maybe I had a
Yeah.
financial question and I always go to one website for my finance question, um, that's kind of a rules-based system. It's just like,
Right.
but
Right.
with principles, I might be able to say something like, oh, go to high quality financial websites that are by people who have backgrounds with a financial perspective that I agree with. That's like a principle that allows an AI to search, thousands of pages and know their backgrounds and search their backgrounds and categorize what they say their financial philosophy is and then look and return results that I would have never even thought about
That's
because
right.
I didn't have the time to do it.
It's like
Um,
a knowledgeable friend who also knows you really well that can give you amazing advice.
exactly.
So in the piece, you say that at Formant, we're inverting the stack. You're talking about starting from principles like safety posture, risk tolerance, cost versus uptime, and then encoding those into AI agents.
Yeah.
What does that mean, and what does that look like in practice?
We see huge opportunities for these LLMs, not just in physical AI of AI running things, but also in setting up, asking questions about data and even in the setup of these robots, right?
Hmm.
By starting from principles, by even just using LLMs to understand what your company is, like even just this very simple Google search of your company can tell you some principles about it, right? And they're not going to be as good as like the ones that your CEO says. But people
Sure.
put out their principles online. So like by starting with this sort of question of like, do we even understand your company, and getting even a few of those written down can vastly help all these aspects of a robotics operation platform. We might be able to
Yeah.
choose the raw streams of your robot faster, right?
Hmm.
We might be able to set up the first dashboard of your robot, emphasizing what you care about, like mushrooms, or maybe its status of loading up a truck or something like that. Obviously, setting up watchers for when you're asleep, right? With principles, we have like a focus of the exploration for an AI to look at while you're, on your coffee break or while you're asleep. And so, by starting with the principles, starting with human values, it really empowers LMs to do all the great things that we think can make a great robotics platform.
You and I often talk about how working with AI feels more akin to management, right? And I think what you're saying is such an interesting illustration of that, right? Much like you would get a new employee into your organization and then teach them how we do things around here. One of
Yeah.
those so powerful things about this is the ability to train them on your context, because there's like typically not right or wrong, right? It's so much is context dependent. And finally, we're at the stage with robotic systems that going from these simple rules that has more of a, either you have to go into exquisite detail about a context environment, or it's going to be more of a one size fits all. You can now literally adapt to context in this extremely powerful way. So historically, a lot of people knew Formant as this robot data and dashboards company. And now we're talking so much more about AI agents that act in physical operations. So for someone who thinks of us as dashboards and observability, how would you describe this shifts toward operations in practical day-to-day terms?
The goal is still the same, right? The goal is still to, create robotics operations that provide human value. We
Hmm.
just now have this new AI helper that can attack very fuzzy problems that we've had to do ourselves historically. What we notice, right, is that, these AIs aren't going to replace a human who's thinking and judging and trying to map it all to what their CEO says is the most important thing. Even sort of like degraded forms of reasonings through LLMs can save people time and de-risk things and give us opportunities to see things through new perspectives very
Right.
quickly.
Right. Yeah, I think that's so interesting what you're saying, right? It's sometimes when people talk about AI, you sort of feel like, oh wow, everything is new in the world, and how do I even begin to understand this? But in a nutshell, what we used to had to learn the hard way was that it was so difficult to move beyond pilots because things weren't scalable. To make this thing we were trying to do with robots actually scale, you had to take more data into account and derive intelligence from all that information. And that just wasn't possible before.
Yeah.
And now that's finally possible in a way that's going to make it practical. And I think that's so interesting, right? Because a lot of the painful deployments we saw in the past really weren't technical problems in so many ways, right? It wasn't like robots that weren't doing what they were supposed to be doing. The machines did what they were advertised as doing, but getting them to work in the wider context of complex physical operations was just brutally difficult. I think that is one of these hard-won lessons, right? It's like we are now much more able to do what we were trying to do all along.
These robots that get deployed out into these environments have oftentimes been very limited to just being understood by very technical people, right? The roboticists themselves were the only person who
Hmm.
could set up the robot. Roboticist was the only person who really knew how to get data out of it, or the roboticist was the only person who could really decipher what these dashboards really meant because they created them. And what I really see, right, is that LLMs provide domain experts to be participating much more in these robotics operations, not only just asking questions and getting more perspectives on like what the robots are doing and where these like inefficiencies are, getting like deep research that asks countless questions and digs through logs to understand like what was the real issue when some mushroom picker failed, right?
Hmm.
I
Hmm.
think LLMs have allowed robotics operation to be more understandable by people beyond just the roboticists themselves. And I
Right,
think
right.
additionally, in the actual operations of the world, these robots that are much more autonomous are being enabled by context that allows their commanding and orchestration to be much more powerful, again, by these same domain experts. It's not a sole programmer that knows how to use AI putting a prompt in some Python script. There's actual tools at Formant that allow domain experts to manage context and see that context be triggered and then get reports on the results of what happened. And I think that's really fascinating.
That is so fascinating, right? I think that's often an undertold story of AI, that AI is incredibly empowering. The new hot programming language is English. What was really hard about a lot of robotics deployment traditionally was that you essentially had to drop in this very sophisticated technology into pretty low technology environments. And in order to make this sophisticated robotic technology work, it needed a deeply specialized operator, really a
Yeah.
roboticist, to make it work. So those two things were just too difficult to do together. And what you're getting at, I think, is pretty profound, which is that non-technical operator who are probably already experts on their physical environment can now start to leverage the power of these tools because
Yeah.
they're not so damn hard to use anymore.
Yeah. Yeah. Easier to set up, easier to observe, easier to automate for vast numbers of situations. And I
Right?
think those are attacking a lot of the problems that have historically created friction in the robotics environment.
That's so interesting. So if we stand on the shoulders of that insight and the optimism that I think that can bring if these technologies are thoughtfully and responsibly deployed, what do you think changes over the next 3 to 5 years for companies that operate in physical
Oh, yeah.
operation that have traditionally been hard to integrate technology into? What
Yeah.
what do you think will feel different?
I think in the future, knowledge management is going to be huge because context is really what unlocks this power of AI automation.
Right?
And in a business environment, right, it's not just context held by one person, it's context that's shared by whole groups of people. And we really are just starting to scratch the surface in ways that we collaborate on this, right? Today, it's like, oh, maybe we have a Google Docs that's shared amongst us today.
Right.
And an AI that we don't quite understand how it even views our own company, right? And I think
Hmm.
in 3 to 5 years, tools that give us transparency into how an AI views us and how it views our organizations are going to be much better. And I think tools that allow us to collaborate on context, to collaborate on principles, and see what those things have affected, they're going to be part of our common life because,
Right.
turning us all into AI managers, will unify us in our need to all be creating great context together.
This is so interesting. When I think about concrete things we're hearing from customers right now is that there are labor shortages. It's really hard to hire and frankly often retain skilled technicians. And this is what you're talking about here is essentially the potential for everybody to know as much as your best, most experienced person, pretty much from day one with these tools, because this context now is easier to retain and improve over time.
AI has the capability for explaining a vast variety of things. I mean, I think we feel very much with AI that we can go on much more deep rabbit holes of exploration than ever before. And I think in a corporate environment, the ability for the domain expert to dig into a whole vast number of problems and become educated very quickly is definitely increasing. Reality matters, right? And then there's something to be said about a person who is very close to particular problems and maybe understanding machines or understanding how certain systems work together very intimately are going to be necessary to be able to judge the AI themselves, right? We can't just trust the AI itself. We know that it hallucinates, and we know that we need to give it better context on how to even improve itself for the next time around. And so it's this interesting dance where, we can't just be managers that are detached from reality in our ivory
Hmm.
towers.
Hmm.
We'll be able to ask a lot more questions, but I think there'll still be an aspect of the future where we got to get our hands a little dirty and see what's actually happening with their own eyes.
Yeah, I like this. I think it's so often lost when we talk about robotics and AI that this is actually an incredible amplification of human skills, and an augmentation is the word we actually should be using much more than automation. Richard, thank you for coming on and for writing this piece. I'll definitely encourage listeners who are interested in this to check out Richard's article. The title is Physical AI from Rules to Principles. It's right there on our Formant blog, which you'll find on formant.ai. So we're going to keep sharing what we learn as we deploy this stuff and make physical AI real. We really like this idea that this is not something that might happen one day. We believe it's real right now. And these AI models, as you outline, is the real unlock. So, Richard, thank you for building this with me, and thank you for your excitement and enthusiasm, and for being an awesome person to work with.
All right. Thank you, Henrik. The future is going to be fun.